Good afternoon. I'm Dr. Kanade. Uh, the topic of our today's lecture is PIC18F458 assembly language programs. In yesterday's lectures, we have seen a couple of programs written in assembly language, and in those programs, we have seen some of the very important concepts related to the data memory access. We have been discussing about this data memory access since long, right? Almost from the second lecture, because the data memory in PIC18F458 is large, and to access a large amount of data memory, it has been divided into banks. Each bank holds 256 bytes, and there are 16 such banks in the PIC18F family. And on the chip, the PIC18F458, we have seven banks actually, and those we access through the access bit and BSR, the combination of access bit and BSR. Some of the instructions which used this kind of access were used in yesterday's programs, and we are going to see another couple of programs which are again based on the instructions that we have studied so far. So far we have seen arithmetic, logic, and data transfer instructions. The programs that we saw yesterday were also based on these types of instructions only. Today also we are going to see some programs which are going to use only arithmetic instructions and data transfer instructions. Okay, so let's go to the today's problem. We are going to see problem number 3 now. Two problems we have already covered. Both the problems were actually adding contents of one file register to another file register and storing the result in a third file register. Okay. In the first problem, all the three registers were from bank 0, or you can also say bank 0, but even also in the access bank section. So we use the access bank type of data access. In the problem 2, all of the three registers were from different banks, bank 2 and bank 3. So we used all the time, we used BSR mode. Now we will see a problem 3 where the registers are not part of a single bank, or in fact you can see the problem statement is quite similar to the first two. Again, it is going to involve the addition of contents of file registers. Okay, there are two file registers which hold some data, and we are going to add those contents of those two file registers and store the result in a third file register. But now in this problem there is a kind of a trick, you can say. These problems, when they are asked, actually the concepts are very simple. That's why there are always there are some small tricks involved in these kind of problems whenever they are asked in your exams. Like, see, the first register is 0x40 and second register is again 0x140. Okay, please note the addresses. Okay, first register is 0x40 and second register is 0x140. The result we have to store in the third file register, which is 0x50. Okay, now what is the trick I was talking about? See, the two registers are expressed in only 8-bit format, and third register is expressed in 12-bit format. Remember, these are addresses of the registers. These are not the data that we want to add. We want to add the data stored inside those registers. Okay, so remember, these are addresses. For two registers, the addresses are given as 8-bit addresses, and for third register the address is given as 12-bit address. So here is the trick that you should pay attention to. Okay, the steps for solving this problem are again very similar to the first two problems. First, copy the contents of first register. Again, note down these brackets. 0x40 is enclosed into round brackets, which indicates the value or the contents of this address. Those contents go into W. Okay, then here the trick I was talking about, the second register address is a 12-bit address. It is not simple 40, it is 140, means it is in bank 1, right? So we have to select bank 1, RAM bank 1, by loading value 01 to BSR, and that is done by using which instruction? Move LB instruction. We will see on the next slide. Okay, so what we have to do in the second step is we have to load the value 01 to BSR, and then when we are adding the contents, we have to take care that we select the BSR mode. Okay, instruction will be the same, add WF will be the instruction, but the mode of the instruction will be BSR mode. Okay, so the third step is add the contents of register 0x140 to the contents of W and store the result in W. So what happens? Again, note the brackets here, means the contents of this address 0x140 plus the contents of W are getting added. Okay, and the result is getting stored in W, means in the working register. However, in the problem, what is asked? Where to store the result? We have to store the result in file register 50. Now, where is this 50? This is if I have given this by if the problem in the problem, if the address is given by 8 bits only, then you have to consider the address as appended by 0 in the MSB nibble. Okay, so this is again part of access bank, so we don't need BSR mode here. Okay, but what we will have to take care is we are not using BSR mode for this instruction when we are moving the data. Okay, are you getting this point? Where I am using BSR and where I am not? See on the
Yes, sir.
yes. Any question? If you have any question, you can ask anytime. Okay. Okay. Now the program. Again, you must prepare this kind of a table. First, in the first column, there should be mnemonic, then there should be operand, and the comments must be given for each instruction or for each step. Remember this thing while writing the program. Okay, so first step was move the or copy the contents of file register 0x40 to W. Okay, the file register was given only 0x40, right? So we can assume, or we should actually assume, that it is 0x040. Okay, whenever it is like this, given like this, then we should assume that it is 0x040. Okay, now where does this register actually falls? Where this register, where is this address in the if you see the data memory map, where does this register fall? I will show you again this diagram. You can see here, this is the actual memory, right? This is the actual data memory where F will be. Okay, F is this 8 bits plus 4 bits coming from here, or you can say 12 bits directly written here. If my register was, what was asked, 0x40, so it comes somewhere here in this section, right? In this section it is, but you can note down that this section is also part of access bank. So like here 0x40 is here. Similarly 0x50 is also here. 040 and 050 both are here in the first section, right? In this first section both the register 40 and 50 are given. So I can access this 40 and 50 using a equal to 0, means using the access bank. Whereas this the second register, what was that? 140, it is somewhere here, right? 140 is in the bank 1, right? So to access register from somewhere here, I will have to use this section, means or this method, a equal to 1 and BSR value will be equal to 1. So this way I will be able to access this register, and using the access bank mode I will be able to access these two registers. Okay, so we are going to use these two methods for solving our problem. So first register 40 I can access using the access bank method. So a is equal to 0 in this case. A here equal to what? A is equal to 0, and move f. What are the parameters here? F D A. D is also 0, right? D is 0, A is 0. Means what? The contents of this register will be copied to D is equal to 0, means destination equal to 0, means to W. Okay. So the contents of 0x40 register will be copied to W. Okay. Now as I said, for accessing the data of this register, we must load value 1 to BSR. So that's what we are going to do. Move LB. This is a special instruction, as we have seen. It will load the literal 01 to B, means BSR. So BSR will become 01, means RAM bank 1 will be selected in this case now. Okay. This is only loading of BSR. To access the actual register content, we must use this kind of format. What we want to do? Add WF, means add contents of W with contents of F. Okay, so W we know already, and what is F in this case? Now remember what I have written here. Please take a note. I have not written 140 here. I have written only 40. Okay, please note this. When we write this F, whenever we write F, it is always only 8 bit. Those 8 bits are the lower 8 bits of the file register address from here. Okay, the lower 8 bits are written in the instruction as F. Okay, then this is D and this is A. Okay, this A is equal to 1. What it means? When A is equal to 1, the upper 4 bits of the F are to be taken from BSR. Okay, that's why now what is the value of BSR? Because of this instruction, it is 1. That's why this 1 is coming from this instruction or from BSR, and the 40, the lower 8 bits are coming from this F, directly from the instruction. So this 140 address is actually a combination of BSR and this 8-bit F. This is how we get the full address. And what this instruction says, the contents of this location are added to the contents of W, and the result is stored in W. Why W? Because D is equal to 0 here. When D is equal to 0, destination is W. If D was equal to 1, the destination would be this file register. So the result would be stored in this register. Okay, so you got this point. This is very important. Again, we have seen same kind of example yesterday also, right? In yesterday's example also, it was the same kind of instruction, right? I will show you again if just to be sure. See here, instruction add WF was there on in yesterday's program also. Again, note down in the instruction when this F is written, F is only 8 bits, 41, and those are the lower 8 bits of the full address. And because of this A equal to 1, because of this A equal to 1, the upper 4 bits are taken from BSR. See, BSR was made 3. So when we say A is equal to 1, it takes the value of BSR as it is into the upper 4 bits of the file register address, and lower 4 bits are taken from this F directly. Okay, so this is how the address is created. Okay, now coming back to our today's problem, the last statement, as they say, store the result in file register 50. Now since 50, as I have shown you before, is part of what? Where is 50 coming from? It is again a part of access bank. So we don't need to specify here. By default, A is equal to 0. Okay. Move WF involves F comma A. Right? There is no D in this instruction. F comma A. So F is 50. A is 0. So it is part of access bank. Okay. So the contents of W will be copied to 0x50 by this way. Okay. So what we are learning basically from these problems is how to access the registers stored in the different locations of the data memory banks. Different banks are available to us. The contents that we want to access may be stored in different parts of that data memory, and we are learning how to access those locations. Okay, now if we will see one different kind of a problem. Okay, this was asked in the latest question paper of AMA. Latest means the end semester exam held in November December. Okay, the problem is like this: after execution of the following program, what will be the contents of working and file register? So a program was given. Okay, there were only 4 steps in the program, and the question asked was like, what would be the contents of working register and file register? Okay, now I will ask one question. I'm not asking the final answer right now yet. I'm asking one question: which file register they are talking about in the problem? See, they are asking about contents of working register means W, right? Contents of W is one question, and another part is file register. Which file register is uh, uh, they are asking about? Somebody tell me now, which file register contents they are asking? Means at the end we are going to write something. The working register contains this value, and the file register, but which file register contains some value? Yes, can somebody answer now, right now? Okay, we will see this by when we come to the end of our lecture. Okay, so what this first instruction is doing, we have seen, remember we have seen all these instructions. There no, I'm not introducing any new instruction right now. We have seen all these instructions in our earlier lectures, and that's what the problems are based on. Okay, so move LW 35H. what will this instruction do? See, here is L, means whatever this is given, it is literal, right? So it is what this instruction will do is it will copy the literal 35 to W. Okay. So what at the end of this instruction, W will have the value 35 hex, hexadecimal value 35, right? Why I'm taking 35 as literal? Because of this instruction, move LW, means move or copy literal to W. That is what the instruction says, right? Now, second instruction is move WF 35H. Now, that's why, see, as I said, the program is simple, but it is tricky. Here also you can see 35H in the first instruction. In second instruction also you can see 35H. But in the first instruction, the 35H was a literal, right? However, in the second instruction, 35H is F. What this instruction does is copy the contents of W to file register F, right? Now this F in this case is 0x35, and since nothing is mentioned in the instruction, by default move WF, what it has, move WF, what this instruction has, comma A is 0 in here given, that's why this is part of access bank. So the register 35x will have the value 35x. Why 35x? Because whatever the contents of W was, it is being copied to F, and contents of W was 35H because of the first instruction. So after first instruction, 35H goes into W. After second instruction, the same value 35H goes into the register 35H. Okay. Remember, in this case, 35 here is a file register address. Okay. Now the third instruction, move LW53H. So this is very same instruction as the first one. So it is going to perform the same operation. The difference is the value. In this case, the literal value is, see, this is a literal value. That literal is getting copied to W. So W now becomes 53H, right? W now becomes 53H. Now the fourth instruction, and WF35H. What this instruction is going to do? Do you remember the syntax of this instruction? And WH, we have seen this instruction, right? And WH and WF. What is the syntax of this instruction? F D A. FDA is the syntax of this instruction. What are these values given here? 0, 0 by default values. So what this instruction is going to do? It is going to AND the values in W and F. Right? What is F in this case? F is 35H. A is 0 means 35H is in the access bank, means it is the same register, right? Here 35H F is equal to 35H is the same register, this one, and this instruction is going to perform what? AND operation between the values. What is the value in this register? 35H. And what is the value in W? 53H. So after execution of this instruction, the result will be 53 and 35. The result is, let's say, you can calculate this, it is 0x11. Remember this thing, okay? Before execution, W was 53. W was 53 before execution of this instruction, and F was 35. F was 35. Note down that this is the value that we have to AND with. Okay. So this is the result of AND operation. However, we have not yet answered our question. What is the question asked? What will be the contents of working register and file register? So working register will contain what? This result of operation 0x11. Since D is 0 in this case, the result of this AND operation is going to the working register. So W will be equal to 0x11. Okay. What about the second section? What is asked? What is the content of file register? Now I am coming back to the first question about this program. Which file register we are talking about? There is only one file register involved in the whole program, and that file register is this 35, right? F is equal to 0x, this was the value, this 35F. All the time whenever there is F, there is only one reference to the address. F is 35H. So that register we are talking about, and that F contains value 35. So as the result is stored in W, the final answer is W is equal to 11H, and file register 35H contains value 35. Okay. So today I am going to give you more time for question answer. We have seen 4 programs, right? Yesterday a couple of programs we have seen, and today we have seen a couple of programs which were all involving arithmetic, logic, and data transfer instructions. All these instructions were mainly focused on what? Basically, what was the learning objective behind these programs? How to use the data memory, how to access the data memory locations. Okay, that was the motive behind today's behind these 4 programs. Okay, so now we will stop and we will open up for question answers. Whatever questions you have regarding this, how access of data memory, or whatever the programs that we have seen, you can please ask.
सर ते प्रॉब्लेम नंबर 3 मगाशी जो आपण प्रोग्राम बघितला ना,
यस
140 वाला,
हा,
तर त्यामध्ये आपण बँक सिलेक्ट केली बीएसआर ला 01 देऊन.
यस,
तर ते कशाच्या अकॉर्डिंग आपण बँक सिलेक्ट करायची, म्हणजे कुठलाही प्रॉब्लेम असेल तरी अकॉर्डिंग टू
इट इज बेस्ड ऑन द ऍड्रेस. ऍक्च्युअली व्हॉट द ऍड्रेस गिवन टू अस वाज 140, right? Here you can see in the problem statement the address was given 140, right? So this value 1 should go to the BSR. Okay. Like in problem 2 also you can see the, let's say here you see the first register was given 240. So what we did, we sent 2 to BSR.
2 to BSR. Okay.
Yes. This one is A is equal to 1, that is going to be either 0 or 1, right? But if we want to use the value from BSR, this will always become 1. This is a single bit. Yeah, that's what probably is confusing to you, whether you have to select that 1 all the time or not. This will be always 1 if you are interested in BSR mode. Okay, but the value of BSR is based on the value of the address of the register. Here it was 140, that's why we loaded 01 to BSR. In problem 2, we changed the value twice. First time we loaded value 02 because the first register we wanted to access was 240. right?
240.
For 240, we loaded BSR
Okay.
equal to 2 here. So that BSR value goes directly as a part of address. Next time we wanted to access 341. So we loaded 03 into
In
BSR
bank.
and that came here. Here also we use the same BSR 3. That's why this 3 came from. That's where this 3 came from. This 1 is equal to this A is 1 actually here. So whenever we say A is equal to 1, it means that we must use BSR. And therefore, whenever we want to use this A is equal to 1, BSR must be set before that instruction.
Okay.
Okay. You got it?
Yes, sir. Yes, sir.
Yeah. Next question.
हॅलो.
Yes.
हा सर आपण मूव्ह WF केलं 0x42 फाईल रजिस्टर मध्ये. तर सर तो ऍड्रेस कॉपी झाला ना तिकडं?
नाही, ऍड्रेस नाही.
व्हॅल्यू असणार.
व्हॅल्यू त्या रजिस्टर मधली व्हॅल्यू कॉपी होणार.
व्हॅल्यू कॉपी होणार.
व्हॅल्यू
सर
कॉपी
ते ऍज ऍड्रेस प्लेस होणार ना ते नंतर?
नाही आय सी, हा एफ जो आहे ना, हा जो 42 आहे हा एफ आहे. एफ म्हणजे फाईल रजिस्टरचा ऍड्रेस. ओके. एफ इज ऍड्रेस. म्हणजे आता हा इथून जसा तयार केला 42 हे लोअर बाईट घेतला आणि ए इज इक्वल टू 1 म्हटल्यामुळे बीएसआर ची जी व्हॅल्यू आहे ती इथे आली. दॅट्स वाय दिस 342 हा आपण तयार केला. दिस इज व्हॉट? दिस इज ऍड्रेस. ओके. या ऍड्रेसला आपण काहीतरी व्हॅल्यू लिहिणार आहे. कुठली व्हॅल्यू? तर डब्ल्यू मधली जी काय व्हॅल्यू असेल या ठिकाणी, ह्या इन्स्ट्रक्शन नंतर काहीतरी आली असेल, त्या डब्ल्यू मधली व्हॅल्यू आपण या ऍड्रेसला लिहिणार आहे. या संपूर्ण प्रोग्राम मध्ये, कम्प्लीट प्रोग्राम मध्ये आपण व्हॅल्यूवर बघितलेलंच नाहीये. म्हणजे कुठल्या व्हॅल्यूवर आपण ऑपरेशन केलंय. आपण काय केलंय, ए प्लस बी असा जो प्रोग्राम लिहितो तसा प्रोग्राम लिहिलाय. सी इज इक्वल टू ए प्लस बी या टाइप मध्ये प्रोग्राम लिहिलाय. बट वी डोंट नो व्हॉट इज ए, व्हॉट इज बी अँड व्हॉट इज सी. जर तुम्ही सी प्रोग्राम लक्षात घेतला असेल कधी, तर लेट से दिस इज ए, किंवा आता कन्फ्युजन नको म्हणून लेट से एक्स, दिस इज वाय. ओके. आणि हा आहे झेड. तर आपण काय केलं प्रोग्राम, झेड इक्वल टू एक्स प्लस वाय असा प्रोग्राम केला आपण. ओके. झेड इज इक्वल टू 342 म्हणजे ऍड्रेस सांगतोय बरं का मी. यांच्यातल्या ऍक्च्युअल व्हॅल्यूज काय आपण अख्ख्या प्रोग्राम मध्ये कुठेही बघितलेलं नाही. पूर्ण प्रोग्राम मध्ये फक्त आपण ऍड्रेसेस बघितलेले आहेत. आणि जे काय होतं ते त्या ऍड्रेस मधली व्हॅल्यू, त्या ऍड्रेस मधली व्हॅल्यू यांचं ऍडिशन, आणि जी ऍडिशन आहे ती तिसऱ्या ऍड्रेस मध्ये स्टोअर केलेली आहे. आलं लक्षात? इथं हा ऍड्रेसच आहे. इथं फक्त आपण या ऍड्रेसला जाऊन व्हॅल्यू टाकणार आहे. म्हणजे नेमकं कसं होतंय बघा. तुम्हाला परत मी ती शेवटची डायग्राम दाखवतोय. सी, ऍड्रेस कुठं होता तो, लेट से 342 ना, 342 हा ऍड्रेस होता. तर ते कुठेतरी इथं असणार आहे, राईट. ह्या ऍड्रेसला हा डब्ल्यू जो आहे, इथं आपण कॅल्क्युलेशन केलं, ही व्हॅल्यू जाईल आणि या ठिकाणी कॉपी होईल. हे किती बिट्स आहेत डब्ल्यू मध्ये? 8 बिट्स आहेत. ते 8 बिट्स इथं लिहिले जातील. 1 2 3 4 5 6 7 8. ओके. ही व्हॅल्यू आपण इथं कॉपी करतोय डब्ल्यू ची. ओके. 342 हा काय आहे? ऍड्रेस आहे. You can see these are addresses of the data memory and the value of W is being copied to this address. आपल्याला डेटा मेमरीत कुठेतरी कॉपी करायचं होतं, कुठं तर 342 ला करायचं होतं. सो 342 आपण ऍड्रेस तयार केला आणि तिथं फक्त ही व्हॅल्यू कॉपी केली. ओके. Remember, whenever we are moving, unless it is like in the last program, unless it is move LW, then only this will be a value. Okay, जर त्या इन्स्ट्रक्शन मध्ये L असेल तरच जे काय आहे ती व्हॅल्यू असणार आहे. अदरवाइज whenever there either in the instruction it will be either L or F. If it is F, it is a what? It is a file register address. If it is L, then only it is a value. म्हणजे या इन्स्ट्रक्शन मध्ये तुम्हाला एक्झाम्पल मध्ये कळेल, क्लिअर होईल की 35H ही जी आहे ही आहे व्हॅल्यू, बिकॉज इन्स्ट्रक्शन इज मूव LW. म्हणून 35 ही व्हॅल्यू इथं गेली W मध्ये. बट हिअर in the second instruction it is move WF. So 35H in this instruction is address. It is not a value. Okay.